1915 Number of Wonderful Substrings. This Java code uses a bitmask to represent the odd-even count status of each letter. Since there are only 10 different letters, A to J, we can use a 10-bit integer, where each bit represents one letter, to keep track of whether the count of each letter is currently odd, 1, or even, 0. We iterate through the string, updating this bitmask as we go, and use a hashmap to count how many times we've seen each bitmask value before. This Java code iterates through each character in the input string. For each character, it updates the bitmask to reflect the current odd-even status of each letter's count. It then checks how many times we've seen this exact bitmask before, which represents a substring ending at the current character with all letters having even counts or exactly one letter having an odd count. It also checks for substrings that could be formed by changing the count of any single letter from odd to even or vice versa, which is done by toggling each bit in the bitmask. Finally, it updates the result and the count of the current bitmask for future iterations. This approach ensures that we count all possible wonderful substrings efficiently. This approach allows us to find the number of wonderful substrings in O(n) time, where n is the length of the input string.